Hello students, I am our educator Ashok Prasad. Today we are going to take on a very important chapter of class 12th, genetics, and you can always expect a question in boards, even in NEET. It's a very important topic. The name of the topic is color blindness. So what exactly is color blindness? Students, you ought to know this color blindness is a genetic disease. That means this disease passes from one generation to another. In color blindness, basically, when you talk about color blindness in this world, around 300 million people are suffering from this very disease, which is genetic disease और अनुवांशिक बीमारी है जिससे दुनिया में करीब 300 मिलियन लोग इस बीमारी से ग्रसित हैं. And we should also know that males are more prone, 8%. That means 1 in 12 men is suffering from this disease, color blindness. Females are quite less prone. That means they are just 0.5%. That means 1 in 200 female or girl is suffering from this disease, color blindness. As we proceed, we'll see why it so. ऐसा क्यों होता है कि बीमारी जो है मेल्स में ज़्यादा प्रेवलेंट है एज कम्पेयर टू फीमेल्स. जब हम क्लास लेंगे आगे तो अपन ये देखेंगे और समझ पाएंगे. Talking about color blindness, generally there are two types of color blindness. One is red and green, the other is yellow and blue. We are more concerned with red and green because it's in our syllabus, red and green color blindness. So today we are going to talk about red and green color blindness. आज हम लाल और हरा कलर ब्लाइंड के बारे में बात करेंगे. और ये जो व्यक्ति होता है जिसको कि हिंदी में भी कॉल इट वर्णांधता बीमारी है. वर्णांधता बीमारी में व्यक्ति लाल और हरे में सही तरह से डिफ्रेंशिएट नहीं कर पाता, कलर्स को पता नहीं लगा पाता. इसके लिए टेस्ट भी हैं. यू कैन इजीली टेस्ट इज ECR टेस्ट इज देयर. यू कैन चेक इट इफ यू आर कलर ब्लाइंड और नॉट. सो कमिंग बैक, दिस color blindness is a Mendelian X-linked sex-linked recessive disorder. In our syllabus, there are two sex-linked diseases. One is color blindness, the other is hemophilia. Hemophilia is also a sex-linked disease. As we have already talked, there are two types of genetic diseases. Basically, one is sex-linked. That means they are present on the sex chromosomes, and the other one is autosomal disease. That means they are not present on sex chromosome but autosome. तो ये जो बीमारी है वो लैंगिक गुणसूत्र पे पाई जाती है और एक्स पर पाई जाती है. सो इसीलिए अपन पाते हैं क्योंकि एक्स में पाई जाती है और फीमेल्स हैव 2x. वी आर अवेयर ऑफ फीमेल्स में नॉर्मल फीमेल में 2x होती है. इसीलिए द चांसेस ऑफ फीमेल बीइंग कलर ब्लाइंडनेस इज क्वाइट लेस एज कंपेयर टू मेल्स. Before we proceed, we should know a basics of the sex chromosomes. If you know, we are always aware, हमको पता है कि in females the sex chromosomes are XX and in males the sex chromosomes are X and Y. महिलाओं में सेक्स क्रोमोसोम XX होता है और पुरुषों में सेक्स क्रोमोसोम XY होता है. और हम पहले ही बात कर चुके हैं कि ये जो बीमारी है ये कौन सी है, एक्स लिंक्ड है और रेसेसिव है. रेसेसिव मतलब क्या है? रेसेसिव का मतलब ये है कि मान लीजिए ये फीमेल है, राइट, दिस इज ए फीमेल. नाउ इफ वन ऑफ हर क्रोमोसोम हैज color blind, other is normal. When you talk about alleles, out of two alleles, one is normal and the other is affected, then this will not allow this to locate itself या प्रकट नहीं होने देगा ये एक्स वाले को. दिस इज वाई द पर्सन विल ओनली सफर इफ बोथ द क्रोमोसोम्स और द एलीज हैव color blindness. So we'll see here again what we can see. If I say this is normal female, right, this is sign for female. In biology you should know this. If the sign for female is this one, this is for female, this is for male, and this is for transgender or the third sex. This is a female, this is for male, and this is for transgender or the third sex. So we can see here what happens is, So this is normal female, this is normal male. Now you see, since this is X-linked disease, so male has only one X chromosome. So male, if X is affected, so the male will be colorblind. A male can never be a carrier because he is having only one X chromosome. Talking about female, female can be a carrier because out of the two X chromosome, one is affected, the other one is not affected. So this one is dominant, will mask this recessive one. This will not allow to uh, this X chromosome, which is normal, will not allow to show itself. So this female will not be colorblind but will pass दिस डिजीज टू इट्स ऑफ स्प्रिंग. आने वाली जनरेशन को क्या करेगी, बीमारी दे देगी. एंड इफ बोथ एक्स क्रोमोसोम्स हैव पुट कलर ब्लाइंड, देन द फीमेल विल बी कलर ब्लाइंड. सो बच्चों, आई एम श्योर एंड दिस अप टू नाउ यू आर क्लियर कि बोथ द डिजीज, कलर ब्लाइंडनेस और हीमोफीलिया, जिसको कि ब्लीडर्स डिजीज भी कहते हैं, जिसमें व्यक्ति का कट लगने के बाद खून रुकता नहीं है, दोनों की दोनों ही मेंडेलियन एक्स लिंक sex-linked recessive disorder. Now, we will see the different cases, what happens when different cases, like when we marry, we are aware of, if both, this is male, right? This is female, this is male. Here, both are normal, like both the alleles are normal. So, the offspring, all the four offsprings, like this XX, this XY, again this XX, and this XY. All the offsprings will be normal, then none will be suffering from color blindness. Now, see the other case, the different cases. Case can be case number 1. What we can see, say, male is colorblind. See, male is colorblind and female is normal. Now, see what will happen. We can see here, when you cross it, this will be a carrier female, right? This two will be a carrier female. This two will be a carrier female. Now see here, this will be a normal male and this will be a normal male. So what we can see, none of the offspring is colorblind, but the females are carrier. Females are carrier and males are normal. Can you get it? Because out of the two, one has only allele for color blindness. So this female will be carrier, this male will be carrier, this will male will be normal, and this male will be normal. So we can say here none of them will be colorblind. Now we can take another case. What we are doing now is case number 2. Male is colorblind and female is carrier, right? Female is carrier. Now see what happens here. The female will be colorblind. Now again we can see the other female will be carrier. One male will be colorblind and one male will be normal. You get what I'm saying? So we can say that 50% of the males, 50% males are colorblind and 50% are normal. When we talk about females, 50% females will be colorblind and 50% will be carrier. Right? Now, we can take one more case. What will that be? We can take like the male is normal and the female is colorblind. The third case is male is normal and the female is colorblind. Now see what happens here. See, this female will be carrier, right? The other female will also be carrier. Male will be colorblind and other male too will be colorblind. So what happens in this case? We can see this like 100% of females are carrier, and here 100% males are colorblind. So you can say once you understand, you can easily calculate the who will be carrier, who will be colorblind, the percentage. Now, one thing you should always remember that a male can never be a carrier. Why? Because you can see males have only one X chromosome, right? Males have only one X chromosome, right? So if this X is affected, so the male will be colorblind. This is colorblind, this is normal. Normal male and colorblind male. Getting what I'm saying? So it's very clear the different cases. Like, so now you can understand. Now the things you can easily understand why males are more affected with this genetic disease known as color blindness, which is 8%. That means 1 in 12 men are colorblind. Because now you can always see females have only one X chromosome. Females have two X chromosome, right? And males have only one X chromosome. And we are aware of that this is X-linked disease. So even in case of females, even one chromosome is affected with color blindness, this female will not be a color blind, but instead will be a carrier. And this one will be, now this is a male. Even if one chromosome is having color blindness, so since this is X-linked, this male will be color blind. This is the reason there is very high percentage of males who are color blind in the population. Right? Now, the last topic we need to talk